Well, here's our next one. Barely fits on the bench. Been kind of putting this one off because it's a big project, but as you can see, it's a big boy. A Pioneer SX1050, 120 watt per channel, toroidal transformer. This was top of the line in its day, or close to it. So it has a couple issues. It's been recapped. Not real pleased with the restore that was done on it, so we're going to redo some things on it. Tuner needs work, just needs gone over. So we're going to go over this and get everything ship shape on it, and then do a test on it and see how it performs. So let's get it apart and test it out. Okay, progress is coming along pretty good on this. A couple of the things that weren't recapped on this machine was the phono stage, which I just redid, and this whole tone stack here. We need to go through and check all this and replace the caps and so forth. And I cleaned the controls. I cleaned all these controls down here. A couple of them were having some problems, especially the speaker selectors. But really what I wanted to talk about a little bit is something that's a little bit different with these particular stereos, these great big monsters. Is there's a circuit in here that we call, in the X-ray business, we call it a soft start circuit. And basically what it does is, these capacitors are huge. They draw an incredible amount of inrush current when you first turn the power on. And so much so that it can actually blow fuses and do all kinds of crazy things. So I printed out this one page to kind of read it and kind of give you an idea of what a soft start circuit is in these big stereos and what it does. So if you look right here, it says, a toroidal core power transformer is employed in the SX1050, which possesses compactness and a large handling capacity. It also exhibits extremely low internal resistance. In combination with the two 22,000 microfarad capacitors, and by the way, these have been upgraded. I've upgraded these, I think they were 33,000. Anyways, bigger capacitors. The surge current accompanying the power switch operation can reach a maximum of, are you ready for this, 130 to 150 amps. Now remember, most circuits in your household are 15 amp circuit breakers. Of course, this is a surge current, but it will definitely blow the incoming fuse here. So a power transformer excitation current is handled by the relay surge protector circuit on the primary side. When the power switch is turned on, the relay S2 drive current flows through R2 and charges C3. So what they're talking about is this resistor here. Now, this is an upgraded resistor. It's on a heat sink. It's a 4.7 ohm. The original one that came with this was this one, and it's a 3.3 ohm. And with the bigger capacitors, I kind of changed it a little bit. I put a little heavier wiring, made sure the contacts on the relay were good and so forth. So basically, it limits the current to approximately 60 amps, which is still a lot of surge current when you think about it. But there's a little schematic of it showing you. It's very simple. And the relay is just driven by a little timer circuit. So I thought that'd be something interesting to talk about. We use, on big DC rail power supplies, it's a common thing to see a soft start circuit that brings the capacitors up softly. Surge current is a huge deal with high-powered equipment for those same reasons. So I thought there'd be something interesting to talk about. Alright, we're back here on this SX1050, and as you can see, we ran into a little bit of a problem. The speaker select switch has always been a little bit flaky on this thing, and I went to check it out and found that this one's a little bit sticky, although it works. This one works pretty good. This one was really bad, and it was pretty shot. As you can see inside, you have these little slider tabs. They're just really thin metal, and they slide on these little tabs that stick up here. They're all soldered on the back. So these aren't real repairable when they do this. So I went online, and for a really good price I found an absolute immaculate replacement one. So I ordered it in. The wires are all cut off. I'm going to have to unwire wrap these, and I'm going to install this in here. As you can see, I got a nice supply of capacitors in, so I can go ahead and finish up this tone control board. So things will be coming together pretty well after that. So that's where we are right now, and I'm going to go ahead and get this swapped out, and then we'll be back. I've got the front end of this back together now. Got this all finished with being recapped. I recapped this power supply, these couple old ones, and touched up the board a little bit. Touched up some of the solder joints. Got this put back together and finished up. So we're right about to the point now where I want to start checking some power supplies. So the next challenge here is going to be looking at the power supply on the other side. The transistors seemed to be getting a little bit too warm for comfort for me, so I'm going to check these out real carefully and see if possibly we have something wrong with a power supply or with a transistor or something. I do know when this came in, it had some shorted transistors that were repaired a while back. One side of the outputs was shorted, so I replaced all of the outputs. This was a couple years ago, and drivers got shorted as a result of that. Then a bad transistor in a power supply, and a bad transistor in a preamp. So this thing had transistor problems. So got everything working, and so last time I used this, it was working. I got the new speaker switch in, and I know that was a problem. So that's all replaced. So we're just taking it one step at a time here. And so we'll get some voltmeters hooked up and start checking some power supplies. So we're on the main rectifier board here on the bottom. And if you look, on pin 9 is ground, pin 7 is your negative 76 volts, pin 6 is your positive 76. So that's my first place I'm going to check right now. So right now on pin 8, which, or wait a second, we are on pin 9 and pin 7. So we should be getting negative 76 volts. So let's turn this on and see how our soft start works and see if this thing comes up. Here we go. Okay, negative 76 is negative 80 right now. Alright, so we'll shut that down, let it bleed off a little bit, and let's move over to 6 and we'll be right back. Okay, pin 6, positive 76. Alright, 78.5, 78.3. Alright, that's good. Alright, I'm going to go through and check these last couple off camera and come back and move on to the front. Okay, we're now over to the main power supply board, which is right here, and you can see there's quite a few voltages here we're going to check. Our plus and minus 60 volts would be our gazinta, meaning that's the voltage going into the circuit. And then it feeds all that and out, so we can derive our 30 volt, 25 volt, minus 13 volt, minus 25, minus 30, plus 13, and plus 5.4. So we're going to check all of those voltages, and I'll do that off camera so I don't bore you to death. But one word of warning I want to give you here is these capacitors that are currently in here are 35,000 microfarads at 80 volts, and they charge up over 60 volts. The potential between the positive and negative is 120 plus volts at very, very high current. This could be lethal. This could severely injure you. So if you work on one of these, you're doing so at your own risk. I can't stress enough that unless you're trained and you understand electronics, understand the safety of how to work with electricity safely, don't try this. Leave it to people who are trained on it. If you're just getting into it, work with smaller systems that are lower voltage or battery operated or something, where you're not dealing with the high voltages. These big stereos are just loaded with a lot of hazardous voltages, as are the tube stereos that we work with, tube amplifiers, and so high voltages, very dangerous. So just a little disclaimer, use caution whenever you do this if you aren't used to working on this type of thing. Alright, so I'm going to move on, and as you can see, I'm checking pins 12 and 13, which is ground and the plus 25 volts. I'm going to go through and check all of those, and if we're all good, then we're going to move on from there. Alright, we'll be back. Okay, all of our voltages on here checked out within a half a volt plus or minus. So I'm going to call this power supply good. I know it was recapped and rebuilt, and the bad transistors were replaced. I even upgraded the heat sink on the big ones. They seem to be running relatively cool now. So I guess the next thing to do is go up to the top side and start looking at our bias voltages and our DC offsets and things like that with the amp. If that all looks good, then I think it's time to hook up the signal generator and do a little performance test on it. Okay, for our first thing, we're looking for DC offset. So I'm looking for pin 17 and pin 4 right there, which is pretty much your speaker terminals. I'm looking for those to be as close to 0 volts as possible. Now, with transistors, the idle current's going to float a little bit, so it's going to kind of buzz around, but it should be roughly 0 volts within a millivolt or two. So, as you can see, I have my 2 digital voltmeters hooked up. I have them both set to millivolt range, and you can see they're both staying really close to 0. Okay. What you're going to find out is if you try to zero it any further than that, that's 1.8 millivolts, for instance, that's not going to hurt anything. You're going to get, it's going to jump all over the place. Those pots just aren't, enough that you can adjust it any better than that. So I'm calling that good. We're going to let it warm up for a little bit, and it'll change a little bit as it heats up, and just give it about 10 minutes or so to cook. And if everything still looks good, then we're going to move on to our bias adjustment. By the way, in case any of you don't understand what DC offset is, or DC balance as they call it here, what that means is you have 2 sets of transistors for each channel, and one half of the transistors handles the positive going cycle, and the other handles the negative going cycle. We call that push-pull circuitry. So what happens is, in a perfect world, they're both going to be centered at 0 volts in between them. So the difference between them will be 0 volts. And then as one set of transistors turns on, it swings positive voltage, and then it goes back down, it crosses the 0 line, and then this side picks up, and then it swings negative. What happens is if one set of transistors is partially turned on and the other is off, you have what's called DC offset. So what's going to happen is you're going to actually have DC voltage sitting on the terminals of your speaker. And of course, we know speakers don't like DC. That will damage your voice coil. So we want that to sit at 0. Okay, so with no sound, no signal, no volume, everything, that your speaker terminal should be silent. So it should have 0 volts on it. So that's what we're looking at right here. And you can even see as this is warming up, this is dropping more and more to 0 volts. This one's still staying around, half a volt plus or minus. So it's very well balanced. So we're good. That's a good sign, right where I left it several years ago. All right, thought you'd like to know that. Okay, we're now looking at the idle current adjustment, or your bias. And basically what we're doing is we're looking at the amount of current flowing through the transistors at idle when there's no signal being applied to it. Now the transistors have to be partially turned on just a little bit. And the reason we do that is when you go through what we call the zero crossing, when the positive going signal shuts off and the negative going signal picks up where it left off, we don't want there to be a trough or an opening or a ditch in between where it goes from that non-conducting state of the transistor to conducting state. So we want the transistors to be turned on, but just turned on, but not enough to actually put DC on the terminal. So not only are we balancing them out, but what we want is when one transistor finishes its cycle or its half cycle, we want the other one to pick up immediately where it left off. If not, you're going to get what's called a crossover distortion. When it crosses over that zero mark, you're going to have a little gap in your sine wave, and it won't be a pure sine wave then. It'll be a sine wave with a little pause in between the half cycles, which is going to sound like distortion. It'll sound terrible. So we put a little bit of idle current. Now if we put too much idle current, you're going to draw excessive heat through the transistors, and we don't want that either. You just want the transistors turned on enough so that they don't go through that zero crossing, but you want them turned off enough that they don't produce heat. So every system is a little bit different depending on the design characteristics of the amplifier. For this one, they're looking at 50 millivolts, okay? And it's after it's been turned on for a little while to warm up. So for 1 to 2 minutes, you do a baseline adjustment at 50, and then after 20 minutes of running, then you want to check it again and make sure it's still 50 millivolts. So that's what we're doing right now. And if you look, once again, we're sitting real close to that. I haven't made any adjustments to this amp yet. It's pretty much rock solid. So I'm going to let it cook for about 10-15 minutes. If it's still here, then I'm not going to touch it. I'm going to keep everything just how it is. I'm pretty pleased with this so far. The next thing we'll do after this is we'll connect up to the dummy load. We'll do our normal test like we've done on the last couple receivers that we did, and we'll see how it performs. We'll check wattage. Hopefully we won't blow out my 100-watt resistors with this 120-watt amplifier. Hopefully my heatsink can take it. If that's all good, then we're going to move on to the tuner last of all. I do know that the tuner had some issues with this as well. It was not very sensitive. All these old receivers this happens to. It might be a capacitor thing. It might be just need alignment. Who knows? But we'll get to one step at a time. These big amps, you just got to do them one step at a time. So we're going to finish this up, and then we'll be moving on to the oscilloscope and signal generator. Okay, we have everything all set to go here. I have the amplifier turned on. I have the signal generator set up on dual channel, putting out 150 millivolt RMS signal at 1 kilohertz into the auxiliary input. I have my dummy load, I have the oscilloscope, and I have the my meter set for AC RMS, true RMS voltage. And we're going to now check and see what kind of output we get here. So let's start bringing the volume up. Okay. Right about there is where we're hitting. And we're getting about 31 volts on one channel and 34 on the other. So it's definitely not balanced. So let's take the worst, which would be 30 volts. So we take 30 volts, which is 900, divided by 8, 112.5 watts. Okay, that's our first one. And boy, those things get warm really quick. And the other one was 34. 144.5 watts. So there's a big power difference. So the first thing we want to make sure is that our balance is set properly. And boy, this thing goes off the charts, doesn't it? Big time. We get doesn't take much to get to go off the scale on this thing. So right now, let's see if we have, those are staying nice and cool. Nice and cool. Alright. It's not bad. Those are all good. Just going through and just doing some spot checks on this. Okay. Let's take it up again. And this time I'm going to actually put them over top of one another here so we get a little better idea. We'll just see if they track. And as you can see, they're not coming up. One channel's bad. Looks like it's the right channel. Oh, now it's good. How do you like that? So I guess we have a dirty balance pot. So let's see here. Alright. What's that? Okay, the wife was asking a question here. Anyway, so basically it looks like our balance pot is not holding. If I just, yeah, look at that. All I got to do is just move it like that, and that right channel goes crazy. So we're going to have to work on that balance pot before we do anything else. And even with the fan cooling, 100 watt resistor doesn't like 130 watts very much, but definitely this is rated at 120 watts per channel, and we can definitely exceed that 120 so far. And this thing isn't even breaking a sweat yet. I think once we get this thing fine-tuned, we're going to probably well exceed that 120 watts. Never ceases to amaze me on these Pioneers how much they exceed their rated power. So anyhow, let's clean the pot and try it again. Okay, so I've taken this out. You can see 3 screws, and this little whole module comes right out. Easy to work on. But as you can see, the openings for the pot are on the bottom. So what I think I'm going to do here is take all these little black screws out along here, take this faceplate off, unsolder the pot, take it out, clean it the proper way, put it all back together, and then we're going to try again and see what we get. So as soon as I get this out, we'll come back. Okay, I desoldered this, pulled it out, just shot the deoxit down inside there, worked it real well, cleaned it up, and now I'm going to reassemble. I'm going to put this back in, resolder it, and get it all back together, put the faceplate back on, and then we're going to give it another try. Okay, I would say so far the hardest part of this whole project has been lifting this big thing back and forth. It weighs a ton. Anyways, we got the pots cleaned up, the balance pot. We got everything put back together. And I just realized I need to put my volume knob on because it's really hard to turn without the knob. So let me, and these knobs actually have little set screws in them. So that ought to do for now. Got everything back up. So let's bring this up. Now I have both traces superimposed right over top of one another, so what we should see is one trace. They shouldn't separate. So let's start coming up. There we go. Look at that, all the way up to there. And you can see it's clipping equally on both sides. Both channels are perfect, and I'm just starting to get the clipping at about 30, let's say 34 volts roughly, which right up there, again, let's just call it 33. $136 watts for a 120 watt receiver. I would call that pretty darn good. So I think this looks good, and I think now the rest of it is we're going to go in and check the tuner and make sure it's properly aligned, and then we'll probably go ahead and I actually have been working on the cabinet out in the wood shop, and we'll go out there and take a look at how that turned out here in a little bit, and we'll go from there. So now we got to get our setup for the tuner alignment. Before we do that, I just want to show you something. I am down at 10 hertz. 10. That's way below what humans can hear. Watch this. I have the volume at maximum, and look how clean that is. Rock solid. Both channels. So this amp is incredible. Let's just try let's go for 20 kilohertz. This is really rough on an amp. So let's see what we get. First of all, we have to bring our time scale way up. See what we get. Look at that. Look all the way up. Wow. Okay, so feeling a little bit adventurous. 30 kilohertz. Here we go again. I just moved the scale. Look, both channels tracking perfectly. All the way up. There it is, full power. So that's 10 cycles up to 30 kilocycles. Perfectly linear, perfect amount with the same amount of amplitude going in. This is a flat, perfect performing amplifier, and excellent. Okay, just thought you'd like to see that. That's the difference between this old gear and the new stuff. The new stuff just doesn't have these great big power supplies, doesn't have the current capability, doesn't have doesn't have the design. Just new stuff just doesn't do it unless it's very high-end and very expensive. So it's well worth investing in an older piece of gear like this and restoring it. Okay, first of all, we're set up to do the AM. That's the first section we're going to do. And I have my 1 k-ohm resistor. I don't know if you can see it down there. Going to my signal generator. I have 30% modulation, AM, 400 hertz. I'm dialed in at 600 kilohertz like it's saying, and it is not 30 dB output. It is minus 30 dBm is what they really meant. Again, that's just kind of the way they wrote it in there. So first thing I noticed is I don't have a full signal, and my pointer is not right on 600. So first thing so our oscillator is off to begin with. If the oscillator was set right, it would be right where we wanted it to be, so right on 600. So the first thing we're going to do is we're going to peak it out. And then they have you fix the oscillator later on at 1400 kilohertz. So let's take T9 and T8, and you can see there's my 400 hertz, and we're going to try to tune it in. I'm going to try to zero this as best I can. I'm pretty much on the signal right there. So let me get a tweaker here, and I'll be back here in a minute. I don't want to waste your time. Okay, so we're back, and I have a tweaker. And the first thing we're supposed to do is T9 and T8, which are these two coils right here. So I'm going to adjust them one at a time. And T9 is the white one. And we're going to go up here and we're just going to see if we can peek that out. Let's take a look and see. That was pretty close. That one wasn't too bad. Now let's go to the other one. Ooh, that one's noisy. That one's noisy. There. That's about as good as I think we're going to get it. And again, we may be looking at some bad capacitors here. I don't know. I haven't recapped the tuner board, and I'm wondering almost if I should. Okay, so it's still out of peak, I think. So we're going to straighten this back out a little bit. Very touchy. Right there. Maybe just a little more. Right there. Okay, that's pretty peaked. Okay, next, signal generator and the tuner to 1400 kilohertz. So we're going to go up here and hit frequency, 1400 kilohertz. We're going to take this and move it up, and it's not going to be on 14. It's probably going to be a little high. There it is, see? And as you can see, we're off. So when you're that far off, you can't just go on 1400. You don't know which direction you want to turn the adjustment. So the first thing we want to do is we want to see T5, 6, and 7. 5, 6, and 7. Okay. So those are right here, and they're marked. AM RF2, AM oscillator, and AM RF1. Okay, so first thing I would say we should go for is the oscillator to bring it in. So first thing, I'm going to purposely bring it closer to this, to my 1400, and I'm also going to make sure that I still have signal. So you see how I diminished it a little bit? So I'm diminished. Now we're going to come down to our AM oscillator. It's very touchy, and we're going to adjust it. And you can see when we hit the peak, it's right there. See it? Now I'm going to bring it a little closer to 140. So I'm going to come a little bit more. And then I'm going to bring it back on again. Right up. There we go. I'm going to go over a little bit. And now I'm going to bring it right on to 140. Nope, not yet. Still got to go a little more. I'm going to have to do a couple more times. And you just have to kind of be patient and bring it a teeny little bit at a time. And don't accidentally get on the wrong trimmer and mess it up. There you go. And one more. And that should put me dead on 1.4 kilohertz. Once we get our oscillator set, there we go. That's pretty well peaked. Then we're going to go to RF1 and RF2 and peak them. So here's RF1 and RF2. So first start with RF1 and go up here and see what that does. And you can see that's pretty well peaked right there. And we're going to go on to AM RF2 I'm going to peak that up. Just like that. That looks pretty good. Make sure everything's right in there. And let's listen to it. And that doesn't sound bad, but I have a little ringing to it. I want to get rid of that ringing. Okay. Not bad. Okay, so we got that. Repeat steps 4 and 7 and adjust for maximum output and minimum deviation at each received frequency. Okay, so now I'm going to go down to my 600 again. So I'm going to do frequency 600 kilohertz. And I'm going to roll down here, and if all is well, this meter should tune in right on 600. Hopefully our oscillator's working. And you can see it's still way off. See how far off it is? It's still too high. Alright. And that could be a number of things. It could be but let's see. It could be a capacitor in here, or it just could be that that's just where the dial is. Sometimes you just can't get it perfect. So we're off at one end, but we got the other end pretty close. So unfortunately, that's just the way it goes. Alright. And again, sometimes you can get that to align better, but a lot of it has to do with the capacitors and things going on inside of here. So we're going to fiddle with it a little more off camera, and then I may recap this. I don't know. Obviously the ceramics aren't bad, but any of these electrolytics, if a voltage is a little bit out on some of these chips and so forth, it can throw that off. So we're going to go ahead and maybe look at that next. But it is working. That's a good thing. Okay, it also says to adjust the AM ferrite antenna, which I did, but I did a little bit different than the instructions. I loosely coupled the antenna like this to the signal generator directly, and that ferrite antenna was way off as far as peaking. So this is a really hot receiver now, so it is picking up very good. So next thing we're going to do is I'm in the basement. Let's just see if we get anything here. I'm going to shut the signal generator off and just see if we pick anything up. A lot of little things. Again, I didn't expect to get much. That's a pretty strong channel.
Ready to make a huge splash and made a huge difference. But yeah, we went down, we paid the car off in 6 months. And we went from there and just started pouring all that into our snowballs.
Very cool. It was good lows. Excellent. How's it feel now?
I checked every day online, the month of April.
It's still a little bit off. There we go. That antenna makes a big difference.
What I'm saying is the ones are privileged and the other ones are free. So you really can't make the analogy that they're saying, but I guess actually Pennsylvania was probably lax state when it comes to gun ownership. A lot of other states, you actually do have to go.
Okay.
They would name similar to from buying a gun. And about 99% of these denials
Okay.
on the...
Good enough. Okay, we're down in the wood shop here, and I've been cleaning up the grill and the cover for the stereo. And as you can see, the original corners of the faceplate, I have those right here. They were pretty dinged up. I mean, they just made the amp look battered and pretty bad. So I had some nice walnut from a tree that fell down from the neighbor's yard, and I cut it up, and I made a couple of new ones, a couple of new ends to replace, and I put some new finish on the cabinet, and it's still a little bit tacky. It's a little bit damp conditions lately with the weather and everything. It's been warm, but it's been kind of damp. So this is going to have to stay down here and dry a little bit longer, and probably in a day or so we'll be ready to put that back together. So I can't put the faceplate back on until these are dry, but they're really sticky still. But I just thought I'd show that to you, and what we're working on out here too. Alright, I just finished up with the AM and FM alignment, and I did it off camera because it's kind of hard to do while holding a camera. But I'll go over the process with you right now. The AM is relatively simple. You basically take a 1K resistor and you run it into the AM antenna port on the back there, and you connect your signal generator, and you just set it to standard amplitude modulated 30%. Basically you just set it at 600 kilohertz, and you go in and you adjust your AM RF adjustments in these two slugs right here. There's basically only 4 adjustments on this, actually 5. So you have your AM oscillator, which is your dial position, your AM RF1, RF2, right there, 1 and 2. So there's 3 adjustments there, sorry. And then you have these 2 right here. And that's pretty much it. You don't have a whole lot of control over your dial position other than that oscillator. You can get it perfect at one end, it might be off a little bit at the other. That could be because of the capacitors or any number of little things, but you basically split the difference, you get it pretty close. Okay. FM is a little bit different story. First of all, I don't have the exact same test equipment that the service manual calls for, so I kind of made do with what I had. And in order to do that, here's kind of what I did. First thing I did was I just took a regular 300 ohm balun, connected it to a piece of 75 ohm coax, and I came up here, and of course this is a 50 ohm output, but it's still not going to be that far out. So basically connected it up there, and they want you to do the first part of the adjustment at 90 megahertz. However, what I found was I have too much other adjacent noise at that frequency, so I went down to 89 megahertz. They want 75 kilohertz plus and minus deviation, FM at 400 cycles modulated, and I started out a little bit higher than negative 95 dBm, but just enough to get, as you can see there, I'm coming out of the record jack. You're just looking at the noise there, and you're looking at the 400 hertz signal. So the first thing we want to do is get it on frequency. So I set the dial exactly where I want it, and then I went over to the oscillator coil here, and I basically adjusted it until I had the exact same amount of noise on either side. So you can see right there, same amount of static on either side. It matches. So I have just enough signal to get some static, but get a nice clear sine wave as well. At that point in time, once you get that lined up, then you can go in and you can adjust your meter centering. So this slug right here, this little can, adjusts center tuning. So technically, if we get center tuned and we got symmetrical signal there, okay, everything should line up. Okay, now once you do that, then you're going to go through and you're going to adjust your RF coils for maximum peak. Then you're going to go through and do your RF capacitors for maximum peak. Then they have you move up to 106 megahertz here and adjust the FM oscillator for your dial scale. So you can get the FM pretty close on the dial scale, which I've done. And if all goes well, if you go by the sound, you can hear when you're on frequency and off frequency. Right there. And you can hear I have it way down. If I go up just a little bit, that makes it clear. And you can see when I get the meter centered, I get clear sound. When I go off, one side distorts. If I go the other way, other side distorts. And you can see when I'm centered there, my meter should be in the black square area for my tuning. And you can see I'm using a very, very, very low signal. And you can crank it way up. And you can see there's maximum signals at about negative 20 dBm or so. Negative 30, somewhere around there. And it'll pick up signal all the way to negative 95 dBm. And even a little further than that. There's negative 105 dBm. I still have a signal. Very staticky. Not even hardly making a reading on the signal meter. But I would say this thing came in really good. Luckily, I did not have to do the multiplex. Now, if we would have had to get into the stereo multiplex, then that would involve injecting signals from the stereo analyzer up here, the SG165. And that's where we would actually put our pilot and our right and left, and we would send that out, your 19 kilohertz and your 65 kilohertz, and you would go ahead through, or 67 kilohertz, and you would go ahead and tune these last couple adjustments here. Fortunately, that was dead on. I didn't have to mess with it. What the problem turned out to be, the FM wasn't working hardly at all, and what it ended up to be was RF coil number 1 was out. And it was out a good bit. I mean, it was about a quarter of a turn. And when I brought that in, all of a sudden the sensitivity came way up, and thing came back beautifully. So I'm going to call this stereo finished. Everything's done. It's working perfectly. I did not recap this. I don't like messing with tuners. It's one of those things. It's like cleaning the grease off of a good working engine. You know, you can't. Nothing ever goes good when you do that. So I'm going to leave these as is. None of them are leaking. All the voltages are perfect. I checked them with the schematic. Okay, so I'm going to call this one a wrap. I'll put the cover on and do a final video of how it looks, and this one will be ready to go. Okay, there she is, all finished and all put together, ready to go. I'll let you hear it for a second and see what it sounds like, but I think this one might be going up on eBay for sale, so I'll link the video to the restoration of this to it. Haven't decided yet, but I'm kind of leaning towards that. Need to thin the herd a little bit, and be sad to see this thing go. It's so nice. But let's listen to it and see how she sounds. Of course, I just have a couple of little Minimus 7 speakers, so of course you're never going to hear what this thing can really do, but at least give you an idea. Here we go. we go. Pretty good. So you get the idea. Alright, that wraps this one up, and more to come later. I have a Pioneer TX 7500 to go on the bench next, and be looking for that coming up pretty soon.